Do you remember this question from the previous podcast? This one right here. Look, I just want to show you a couple things on this again, just to kind of remind you. Remember that we factored out a 2. This gave us an x squared minus 2x minus 3. Remember we PSA'd this. And when we PSA'd this, we found out the factors were x minus 3 and x plus 1, giving us, of course, our critical points, our non-permissible values to be x equals to 3 and minus 1. We plotted it here. There's the minus 1. There's the 1, 2, 3 right here. And we know that this thing is opening up. And the reason why it's opening up is because that's a positive value, right? Right. Great. I want you to keep all of that in mind when I show you the very next question. Remember what our question looked like. It was 2x squared minus 4x minus 6. Ready? Watch this question. Watch what I do. Boom. I took the exact same question, but look what I did. It's now minus 2x squared plus 4x plus 6. All I did is I changed everything here to a negative. So in other words, I put a negative in front of that entire question that we just had. And I want to look at how did this question change just because I made this a negative. Okay, so let's start with this question then and watch what happens. This is the cool part. This one, of course, we have to now factor out, but now we factor out not just a 2, but we actually factor out a negative 2. We factor, there we go, x squared minus 2x minus 3. But in fact, if you look at it, by factoring out that negative 2, this equation is exactly the same. There's no difference in this equation. I'll prove that to you by going back and forth. Look, x squared minus 2x minus 3. Take a look at this guy. X squared minus 2x minus 3. There it is, exactly the same. So what changes? The only thing that changes here up front is the negative. That's the only thing that's changing. And it tells you that that a value now, being that it's negative, means that this parabola opens down. In the last question, that was positive. That was a positive value. It was greater than 0, meaning that it opens up. So how does this change our reciprocal functions? That's why I'm looking at this particular question again. How does this change our reciprocal function? Well, honestly, that doesn't change, does it? Look, if you PSA this and you factor it again, you still get x minus 3, x plus 1, right? And look at this. Now, this is the cool part. You still get the same critical points, 3 and minus 1, exactly what we had on the previous graph, 3 and minus 1. That has not changed. So you're probably saying, well, wait a second. Doesn't that negative change things? Doesn't that flip things? Yeah, but look, if our previous intercepts were here and here, it doesn't matter which direction this graph is in, those intercepts stay the same. They have not changed. Those x-intercepts do not change when you flip the graph. Those are, in fact, invariant points in this case. Now, what does change? What does change is the fact that in the previous one, you had a minimum value, now you have a maximum value. That's what the negative tells you. You have a maximum. So let's go and start graphing this and see what happens. First things first, let's find that vertex. Remember, when you're at this point here and this point here, the vertex is right exactly in the middle. So just count. 1, 2, 3, 4. Isn't that nice? 4 divided by 2 in the middle means it's 2, so it's got to be right at that point. And remember, x does not equal to 2. X actually equals to 1. Be very, very careful. That coordinate of this point right here is 1 comma something for your vertex. So make sure that you substitute a 1 in. Even though you move 2 units over, this is actually a position of 1 on your graph. So be careful about that. Okay, so how do we figure out what our vertex is? Go back to the original. All right, so minus 2. 1 squared plus 4 times 1. Plus 6. Okay, so this becomes 1 squared is 1 times minus 2 is minus 2. That's 4, that's 6. All right, 4 and 6 is 10. Subtract 2. That gives you a vertex of 8. So at 1, 2, 3, 4, 5, 6, 7, 8. Way up here is the original graph coming down this way, like that. Bada boom. Bada boom. There's your original graph. Now, think about it. You still have an intercept here at plus 6. Let's check. 1, 2, 3, 4, 5. Yep. Wow, that's perfect. That's an excellent sketch of this particular graph. Now, don't forget, how do we do the reciprocal now? Remember what this maximum was. That maximum was 1 comma, we just figured it out right here, 1 comma 8. So when we reciprocate it, this of course becomes, this guy right here becomes 1 over 8. All right, so there's our point right about there. Now, a couple other things that we have to put down. Asymptotes. Da 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 da. There's your asymptote 1. Da 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 da. There's your asymptote 2. Excellent. Now, here we go. Invariant points. There's one here. There's one here. Remember, that's when y equals to 1. And when y equals to minus 1 is our other invariant points. Right here and, of course, right here. So how's this graph going to look? Comes down right like this. Goes through that invariant point, comes down to that vertex, then goes up. Keep on going on this side. Comes around this way and down. Comes around this way and down. And if you look at this particular graph, because this is a negative, this reciprocal is also flipped. We went from a graph that was like this, right, to a graph that is now like that. And that's how you do these particular questions. Everything else, same old, same old. But I wanted you to see one that was actually flipped, and it's pretty darn cool.